Okay, welcome back everyone to Math 131. Math 131. We are now on lecture 4, and last time we began our textbook exercises or content, chapter 1, section 2. Started talking about slopes of curves at a point. We were just trying to get a general overview at the last lesson. Today we're going to be really serious. Then we're going to go into section 1.3. I'm going to sort of combine both of these sections because 1.2 is a little bit of an overview, and then 1.3 starts to get into the details. So I'm going to also cover section 1.3, which is the derivative. We're going to look at notation. Proper notation is important because you're making accurate mathematical statements. And so we want to be able to do that. In section 1.3, we learned one of many rules. This is only one rule. In section 1.3, it's called the power rule. Just the beginning of the derivative. So after we cover this, then we're going to go to the textbook exercises for section 1.2 and 1.3. I just like to kind of do a cleanup, show you where it is in the book. We work some problems together. You help me out. And then we're going to move on into the concept of limits. That's a very important concept in calculus. And in fact, the derivative, I'm just giving you a rule today because this book likes to give you the rule, say, trust me, it did fall out of the sky and it works. And then it comes back and tells you where it came from. So to understand really where limits come from, derivatives come from, we have to understand the concept of limits, which actually goes on to other calculus concepts as well. So we'll get a rule today. You'll just say, okay, that's the way it is. We just use the rule. But then section 1.4 comes back and explains where that derivative came from. But we have to understand limits first. All right, is everybody good? Any questions before we start? All right, well, I had a few little warm-up questions because I asked you to spend your Saturday night going back in chapter 0. So I'm just going to call these review warm-ups. Okay, and the first, this is from chapter 0. Just a couple things we got to be good at in order to continue on in our calculus. The first instructions are going to be simplify without a calculator. And also simplify is going to mean answer with no negative exponents. Okay, so what I'm going to do is put down an expression. I'm going to wait about 3 seconds. You're going to tell your neighbor what the answer is, and then you tell me. Got it? So don't yell out the answer until I ask you to. This will give our people watching it by video time to find somebody else in the house to talk to. All right, the first one that you want to simplify is 36 raised to the 1/2. 36 to the 1/2. Tell your neighbor. Whoa, I don't hear much in here. All right, what is it? Oh, because it was too easy. All right, 36 to the 1/2 means you're taking the square root of 36, and it's asking you, what do you multiply times itself 2 times? That gives you 36, and that is 6. All right, make me feel good. How many knew that right off? Raise your hand. Whoa, I don't feel good when hands don't go up. Next one. I think I'll go easy since every hand didn't go up. I'm going to just ask you to tell me what. Don't tell me yet. 2 to the negative 1. 2 to the negative 1. Tell your neighbor. Tell me. 1/2. This means that the rule is a to the negative m means 1 over a raised to the m. Some of you should have stayed in Saturday night studying this. All right, you're going to have to stay the rest of the week in. So this would be 1/2 raised to the first, or 1/2, if you're trying to make the rule fit exactly. All right, next example. Don't say it till I ask you. 8 to the negative 2/3. You've got to be good at this, or you will not do good on your test. That's a negative 2/3, right? Can't read it. 8 to the negative 2/3. Okay, tell your neighbor. Okay, what is it?
1/4.
1/4? All right, let's go step by step. How are you going to deal with a negative exponent? Yes, it's going to be 1/8 to the 2/3 power. And your rule is A raised to the m/n when it is reduced to lowest terms. When it is reduced to lowest terms. m/n reduced to lowest terms is the which root? Nth root of A raised to the m. Okay? So this means I'm going to take the cube root of 1/8 and then square it. So what do you multiply times itself 3 times to give you 1/8? That's not a trick question. What do you say times itself 3 times to give you 8? 2. So 1/8, the cube root of 1/8 is a half. We'll square that and 1/4. All right, I'm going to pass around a red pen. All you who are not getting it, write yourself a note to work, work, work. In section 0 on negative exponents, pull out your pre-calculus book. Pass that pen right around. Since I'm not getting many responses, I need more red pens going. Send them. All right, how are we doing? Not so good. Try another one. All right, what about this one? Simplify this. Don't tell me yet. What is it? 9. You're just multiplying negative 3 times negative 3 and you get positive 9. All right, what's this one? Don't tell me yet. Minus 3 squared. Tell your neighbor. Right. The exponent only goes with what it's next to unless you have parentheses. So this is really like minus 1 times 3 squared. Might need to mark that with red. Minus 1 times 9 or negative 9. Students often get confused here. Be very careful. Your exponent only goes with the base that it's next to. All right, next example. Simplify this. 3x to the negative 2 times y over x cubed y to the 5th. 3 times x to the negative 2 times y over x cubed times y to the 5th. Okay, let me hear a final answer. Tell your neighbor the final answer. All right, let me hear some answers.
3x over y to the 4th.
3x over y to the 4th. Wrong? Somebody give me another one. I mean, I'm not saying that's wrong. Somebody said it was wrong, not me. What do you think? X to the 5th, y to the 4th. Okay, what's another one? All right, let's see what it's going to be. And we're just going to do every little step that once you have gone back and reviewed chapter 0, you wouldn't have to put in every little step. But this is all multiplication. 3 times x to the negative 2 times y. So we could write this as 3 times, and then x to the negative 2. I'm just going to sort of break it up like this. 3 over 1 I didn't mean to put a dot there, times x to the negative 2 over x cubed times y over y to the fifth, because it's all multiplication with the fractions. And 3 over 1 is just 3, so far this part is correct on both of these. Now we have a x to the negative 2 over x cubed. How do you handle that negative exponent? Okay, so this little part right here, this x to the negative 2 comes down to a 1 over x squared, and then you've still got it times 1 over x cubed. The x to the negative 2 came down in the denominator times that x cubed there. So when the bases are the same, what do you do to the exponents? Add them. So that would be a 1 over x to the fifth, and that part is totally correct right there. Who got that x up in the numerator? I want to hear what you did to get that. You can tell me.
I just didn't know what to do, so that's why I put it.
Oh, it was a guessing game?
Mm-hmm.
Don't guess. Okay.
I got the 3 right.
You got the 3 right. Okay, that's partial credit. Okay, y over y to the fifth, and everybody looks like they got y to the fourth, because what you're looking at for this part is you've got 1y in the numerator, you have 5 of them in the denominator, and so y over y is equal to 1, because we're assuming y is not 0, so you get 1 over y to the fourth. All right? Keep that red pen moving around if you're not getting these. All right, next example. We got to be able to remember how to work with fractions once we start taking some derivatives. You haven't done arithmetic in a while. 1/4 minus 2/3. Ooh, that's not the right seat. Okay, what'd you have to do to say 1/4 minus 2/3? Common denominator, which is 12. Oh, good. We're good with arithmetic. All right, so 1/4, you probably multiplied that times 3 over 3. So that would give you 3 minus, and 2/3 you multiplied by 4 over 4. And so 3 minus 8 is, I think, what, a negative 5? Negative 5/12. All right, we're good with fractions. Yay. All right. Given f of x equals x squared plus 2 over x, find f of negative 1. F of x is x squared plus 2 over x. Find f of negative 1. What's the answer? Negative 1. What did everybody do? Replace the x with negative 1. And you get negative 1 squared plus 2 over negative 1. Negative 1 squared is positive 1 plus 2 over negative 1 is a minus 2, and you got negative 1. Relative to a graph, a visual, what did I just find?
The y-intercept?
Mm-mm.
The points on the
That's
line.
y equals mx plus b. When I found
Found what y
I
equals
found a
to.
point on the curve, didn't I? So if I were graphing this thing, which one is the, oh, well, unfortunately, they both came out to be negative 1s, didn't they? All right, let me just change a number real fast so we don't have negative 1s. Let's do f positive 1. That would be 1 plus 2, 3. Okay, so if I were going to plot a point, it would be the point what? 1, 3. Okay, f of says, what is the y value? F is a function of x. Y in terms of x. So what is the y value when x is 1? When x is 1, y is 3. Okay? We have to remember things like that. Okay, the next things we need. Oh, was that too fast? Everybody good? Okay, the next thing is a little vocabulary. Find the zeros. Zeros of, I got these right out of the chapter 0 exercises at the end of the chapter. Y equals 5x squared plus 3x minus 2. Find the zeros of y equals 5x squared plus 3x minus 2. All right, what does zeros mean? All right, find the zeros. It says find the values of x where the y value is 0, which is exactly what you said, x-intercepts. All right, zeros mean what makes the y value 0, zeros of the function. All right, so take about 3 seconds and solve this. Okay, what's the name for this equation? It's called a quadratic equation. All right, to solve a quadratic equation, you might use a quadratic formula. What is the quadratic formula? X equals
minus square root
b squared minus 4ac.
the whole thing over 2a. So this is called the quadratic formula used to solve a quadratic equation, which is ax squared plus bx plus c, right? Quadratic formula solves for x for a quadratic equation. This is an equation. Up here, y equals 5x squared plus 3x minus 2 is called a what? Quadratic function. It's a quadratic function. It's got the x's and the y's in it. Remind me what the graph of this thing would look like. Parabolas that open up or down? Up. So will it have a max or a min value? Minimum value. What's the y-intercept? -2. Exactly. Let x be 0, y is -2. All right, but this was asking for the x-intercepts. When you have a quadratic equation, there are 3 ways to solve a quadratic equation. One you've just told me, use a quadratic formula. What's another way? Factor if you can, and if you're going to factor, it's got to be the rule a times b set equal to 0 if. So one way is quadratic formula. Second way is if you can factor it equal to 0, then a equals 0 or b equals 0. What's another way you learned? I'm not even going to repeat what you said. What's another way that you should have learned? Complete the square. Remember completing the square? All right, but you can, one reason for learning to complete the square is so you can get into your quadratic formula. All right, did this one factor? Yes. So if you can factor it correctly, jump right on it. We have a 5x and an x, and this -2, we'll put a 2 here, -1 plus 2. Does that work? 5x squared? No, it does not. Negative goes right here. 5x minus 2x is 3x, -2 times 1 is -2. All right, so now we have 2 factors multiplied together equal to 0. Then that means that 5x minus 2 equals 0, or x plus 1 equals 0. So x is what, 2/5, or x is -1. Solving those 2 little linear equations. That means that if I put these values back in here, it makes a true statement. But by letting the y value be 0, this is where the graph will cross the x-axis. Everybody got it? Okay, this is We did some problems from Chapter 1, Section 1, I think. Yeah. On last time when we were talking about slopes of lines and equations of lines and all that stuff. I want to go down to problem number 45. We've got a visual here. This is page 69, problem number 45. And we have two lines that are intersecting the graph of a function. The blue is the function f of x. We have two lines intersecting that function. One line is y equals minus x plus 4, and the other one is y equals 2. The question is asking me to find a f of a f of a. And what is that relative to my graph here? Yes, the intersection of the curve and the two lines, right? So I'm looking for a f of a. I'm looking for an x value and a y value, and I know this line is y equals 2, and this line is y equals minus x plus 4. So do I immediately know part of my answer already? What? Yeah, this line and this line are intersecting at y equal to 2, so I already know my f of a, my y value here, has to be 2. All right, now, how do you think that I'm going to figure out what the x value is? Yeah, just substitute into probably this equation, y equals minus x plus 4, because it also is intersecting at y equal 2. So we'll put a y value there for 2. I probably should not keep writing in my book, should I? All right, let's see. Move that up just a little bit. And we have y equals negative x plus 4. We already know that y is 2. So we'll just solve this little linear equation. Subtract 4 from both sides, and we get negative 6 equals negative x. So then what is x going to be equal to, everybody? 6. So we found the point 6, 2. Okay, everybody good? All right. Now you do number 46. Same problem. Well, same type of question. We have the curve f of x, and everybody, all these other curves, y equals x and y equals 1/2 x plus 1, they're intersecting at this point a, f of a. So you have to find a, and you have to find the y value. Yeah, talk to your neighbor about it. Okay, tell me what you're thinking that you're going to do. What are you going to do to solve this?
Ask for help.
Set the two y's equal to each other. Right, you're really looking at the point of intersection of two straight lines, and where they intersect, the y's have to be equal to each other at that point. So one y is x, and the other y is 1/2 x plus 1. Just using a substitution method. Set the two equations equal to each other. All right, so let's add 1/2 x to both sides, and what do I get over on the left? 1 plus 1/2. Oh, I'm subtracting 1/2. 1/2, right? Subtract 1/2 x from both sides. I was adding. Big mistake. All right.
Maybe a
Negative 1/2.
negative 1/2 x on the left.
Yeah.
Well, let's see.
That's
You're
the-
subtracting 1/2 from.
Oh, no,
I got
you're right.
Oh,
1x
that's one, you're right, my bad.
minus 1/2 x. 1 minus a half is a half. I could have been wrong, so good to double check. All right, so I subtracted 1. I had 1 minus a half gives me a half. Multiply both sides by 2, so x is equal to 2. And so my a then is going to correspond to 2, and the other question asked me to find f of a. So I'm looking for f of 2, and what is f of 2? 2. Either one of those equations you put it back in will work. So it's the ordered pair 2, 2. All right, we're good, everybody, correct? All right. Okay, that's in with the review. You know what you need to do? Where are those red pens? Have you run out of ink marking all the things you need to go back and review? Red pen still floating around? All right, we're jumping now in Chapter 1, Section 2, and we're sort of doing Chapter 1, Section 3 at the same time, and then I'll back up and clean it all up. All right, so we're in Chapter 1, Section 2, and Chapter 1, Section 3. All right, at the end of the last lecture, we were introduced to slope of a curve at a point. We have a curve. This is in the coordinate system. And we want to know what is the slope of this curve at the point A, f of a. Slope of a curve at a point. All right, we'd always talked about a slope of a straight line. Change in y over change in x. Okay, so in order for us to carry on that theme, we have to come in and look at a line that best fits the curve at a point. That if you blew it up around this point, it is a straight line that best fits the curve right there. What's that line called? Tangent line. So the slope of a curve at a point is going to be the slope of the tangent line of the curve at the point. Okay, so if we blew this up and tried to draw in the line that best fit the curve through that point, we would have a straight line that looks something like this. All right, and that would be the tangent line. A tangent line best describes a point. The tangent line best describes the curve very near that point. You got to be really close to that point so that when you blow it up, it looks like a little straight line through there. All right, so we have to get a little tangent line. And then on the last lecture, I said, hey, this is called the derivative. The derivative. All right, so before I give you the rule right out of the book and you say, great, I trust you on that, let's get some notation. Notation for the derivative. All right, normally we have y expressed as a function of x, like y equals f of x equals x squared or whatever. So for the derivative, all right, somebody impress me who's already done this before. What's some notation I can use for the derivative? Okay, I'll tell you. All right, for one thing, we are going to take the derivative of y with respect to x. This says that my function is y, my independent variable is x. I'm taking the derivative of y with respect to x. Okay? Other notation you might use is f prime of x. Use a little prime there. That says I'm using my function f. A little prime there means I'm taking the derivative of that function and my variable is x. Okay? And sometimes, let me just put a function here, something like x cubed plus 7. Sometimes other notation we see is it says I'm going to take the derivative and instead of writing y, I'm going to put what the y actually is. So I would put in parentheses x cubed plus 7 dx. So instead of putting y, I state what the function y is and then put it over dx. Okay, everybody got that? All right, now, people who've done this for a while get really, really lazy. And this is not good. But I'm just letting you know, I bet I slip up and do this sometime in class. It is okay. It is accepted. It is not the best. Some people will go y prime for derivative. Now, the thing that's not good to just do y prime is it's not telling you what the variable is that you're taking the derivative of. In the next math course, you're going to be working with functions of more than two variables. You might have y as a function of x and z, and you'll be working what is called partial derivatives, and you need to say which variable you're working with. But if you only have y as a function of x, a lot of times we'll just use a y prime. Okay? Now, based on that, we're going to do what's called critical thinking skills. Suppose I wrote that s of t is equal to t squared plus 7 for my example. What would you guess the notation would be for the derivative? S of t equals t squared plus 7. What notation would you use here for the derivative? Okay, you could do s of t squared plus 7 over, oh wait, it's not d, it's not s, it's d of s over dt, or ds dt, or s prime of t. Very good. All right, it's the same thing as saying something like f of x. I know why this one was confusing to you right here. You could have called it a y. You can still call it s. Sometimes you write functions like s is equal to t squared plus 7, so you could get away with saying ds dt. S is my function. All right, so s prime of t, ds dt says that s is my function, my variable is t, or I'm taking the derivative of t squared plus 7 over dt. Okay, all those notations. All right, so let's just go for the rule. We're going to play with the rule, and then we'll also try to say at the same time what the rule means. Let's see, we're on, where is it? Yes, thank you, page 81. And this is the power rule for the derivative. Page 81 at the top. Okay? It says let R, this is the first of many rules. This is the basics for us beginning. Let R be any number. So that means that R can be positive, negative, zeros, fractions, irrational numbers, pi, can be any number. Let R be any number. We're talking about real numbers, by the way. And let f of x, the function, be x raised to the r. This is x only raised to the r. This is not like x squared plus 7 raised to the 12th. It is x only. So if you're writing in your book or writing on your paper, make yourself a note in red. This is x only raised to the r. It is not anything like parentheses x cubed plus 25x plus 2. It is x only raised to the r. Okay. Then the derivative is, and this is all I say, bring the r down in front, rewrite x, decrease it by 1. That is the derivative. And as soon as I say the word derivative, your brain also thinks two other things right away. What do you think? Slope of the curve at a point, slope of tangent line to the curve at a point. All right, everybody see the rule? Everybody see the rule? All right, let's have some fun. All right, if you have f of x equals x raised to the r, the derivative, which is the slope of the curve, slope of the tangent line to the curve at a point, is r x to the r minus 1. All right, here's our first example. F of x equals x squared. Let's find the derivative. Let's find the derivative at x. All right, tell your neighbor what it is. Just following the rules. Okay, now you tell me. 2x to the 2 minus 1, which is just 2x. Now let's get a visual on what we just found. What is the graph of f of x equal x squared, buddy? That seems too easy. What is it? Parabola. It's going to go through 0, 0, 1, 1, negative 1, 1. It's going to look like this. Oops. All right, so we have f of x equals x squared. Now, when I found the derivative, I have found a formula for the slope of the curve at any point on the curve. All right, so if I want to find the derivative at 1, how do I determine what the derivative evaluated at 1 is? Put 1 in the derivative function. So we have 2 times 1 or 2. So now I'm going to go to the point when x is 1. Remember, this is the point 1, 1. When x is 1, y is 1. Let me put that up here. F of 1 equals 1. All right, at the point 1, 1, when I find the derivative at 1 as 2, I have actually found that the slope of the curve right here is 2 units. It is a better visual if you come in and put a little tangent line coming through here. Oops, that was a bad tangent line. Tangent line coming through. The line that best fits the curve near that point, the slope of that tangent line is 2, and we can say the slope of the curve at the point 1, 1 is 2. All right, explain that to your neighbor. Explain this part right here to your neighbor. Verbalize it. Go.
Did you understand it?
Tell me.
Okay, now I need a volunteer. If you'll verbalize it, it'll stay in your memory. Who will say it for me? Thank you.
The slope of the tangent line at the point 1, 1 of the curve is 2.
Okay, the slope of the tangent line to the curve, which is also actually the slope of the curve itself, at the point 1, 1 is 2. Perfect. All right, now I want you to write the equation of the tangent line. I always put these on tests, by the way. Tangent line to the curve f of x equals x squared at x equal to 1. I want you to write the equation of this tangent line to the curve f of x equals x squared at x equals 1. Okay, talk to your neighbor about it. What do you need to write the equation of a line? Do you have it? What do you need, and do you have it? Okay, what do you need to write the equation of any line? You need a slope, and what else do you need?
A y-intercept.
Well, you can do it without a y-intercept. What else do you need? A point. If you've got a point and a slope, can't you write the equation of a line? What do we have already from this problem? We have a point, and we have the slope at that point, and I want the equation of the tangent line at that point 1, 1. All right, so the point is 1, 1. You just found the slope up here is 2. You can write it as m equals 2 because you're writing an equation of a line, right? And if we use point slope form in life easy, what's it going to be? Y minus 1, that's the y coordinate, equals slope times x minus 1. That's a perfectly great equation of a line. If you want to rewrite it as y equals, go for it. Okay, that you can write it as y equals. But that's a perfectly great equation of a line. Okay? All right, you ready for another question? Yes, you are. Can't wait. All right, we're going to stay with y equals x squared for a minute. All right, f of x equals x squared. I want you to, this is normally the way I write a question on a test. I give you y equals x squared or something like this. And I would say write the equation of the tangent line to the curve at x equal negative 10. All right, so I'm not leading you this time. I'm not leading you step by step. Y equals x squared. We want you to write the equation of the tangent line to the curve at x equals negative 10. Go for it. Put those calculators away. Those are security blankets. You don't need a security blanket. Okay, let me hear some answers.
Y minus 100.
Y minus 100 equals
Negative 20.
negative 20
In parentheses, x plus 10.
x plus 10. How many vote for that being the correct answer? Raise your hand high. 2, 3,
Oh, yeah, I'll go with it.
4. Let me hear another answer.
It's simplified form is.
Say it again.
It's a simplified form is y
Oh.
equal to minus 20x minus 100.
So that came out to be plus 100 minus 20x plus 100.
Minus 100.
I know, but negative 20 times 10 is negative 200. Oh, yeah, minus 100. Sorry. And added 100. Okay, same thing, though. All right, what's the thought process? You've got to write the equation of a line. You need a point. You need a slope. You've got a little bit of the point started here. X is negative 10. Where do you find the y value when x is negative 10?
Plug it in the equation.
Oh, y is not a derivative. Y is a slope. So this is the, remember, y is your function of x. So when x is negative 10, the y value is 100. when you need a slope, your brain, slope of a curve, your brain goes to the derivative. You find the formula for the derivative that will give you the slope anywhere, and then you got to find it particularly at -10. So x squared, the slope, the formula for the slope anywhere is 2x. You need it when x is -10. So 2 times -10 is -20. So you've got your point, you've got your slope, you got your equation for the line. Perfect. Okay? So start a problem with what do I need to be able to do it? Then where do I go from there? All right, so basically, if I were trying to look at the graph of y equals x squared, wherever -10 is, way over here somewhere, oops, the slope of the curve is -20. The slope of the tangent line to the curve is -20. You can see that's a negative slope. It's coming down. The y values are getting smaller. And then this would be the equation of the tangent line. All right, everybody doing good? All right, let's make it a little more interesting. Each one's going to be a little more interesting. I want you to find the point on the curve f of x equals x squared, where the slope of the curve is 30. Find the point on the curve, f of x equals x squared. Find the point on the curve where the slope of the curve is 30. The slope of the curve is 30. Talk it out to your neighbors. What do you have to do here? I am seeing correct answers from where I'm sitting, and I heard your correct answer. Good. 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 All right, are you starting with the words slope is 30? How do you translate is in math? Equal. All right, how do you translate slope of curve? The derivative is 30. Derivative is 30. Do we know the derivative of x squared?
Yes.
Yeah, using the power rule, and that is 2x is 30. X is 15. Is that my final answer? No, because I'm looking for a point. A point is x, y. So I have to find the y value that goes with 15. So it would be 15 squared, which is 225. Okay? Everybody doing good? All right, let's review what you've done, because these are major concepts that we did very quickly with one simple problem. So let me flip back a page. We looked at our basic power rule. It is the variable x raised to an r. It's r x to the r minus 1. That is a derivative. When we hear derivative, we think of slope of the curve, slope of tangent line to the curve. There are a lot of other things the derivative's going to be, but right this minute, this is all the beginning of our understanding. All right, so if I'm given a function, when I take the derivative, I have found a general formula that whenever I plug in that value for x, I think it's called substitute in math, but it's plug. You plug in that value for x, it will give me the slope anywhere. Notice that if I were at x equal to 0 here, wouldn't my derivative be 0, because I would, my little tangent line here would be horizontal at x equal to 0. 2 times 0. If I have a negative x value, all the tangent lines on this side would be negative slope. All the tangent lines when x is bigger is positive slopes, and they all work beautifully in this little formula. All right, so once I get a general formula for the slope of the curve, then if I want to know at a particular value of x, I substitute it in. In order to write any equation of a line, we have to have a point and a slope, and that's what you found. We wrote the equation of the tangent line here at x equal -10. So you had the first part of the point. You find the y value. This is y equals. You got to go back up here. When you were looking for the slope, you substituted the -10 into the formula for the slope, which is the derivative. So once you have a point and a slope, then you can easily write the equation of a line. You can make it more interesting to find the point on the curve where the slope is a number. But you translate the word slope of a curve, that is a derivative. Derivative is 30. We come back and look at the function and put in, well, what is that derivative? 2x. We're able to solve for x. We were looking for y, so we go back to the function. Everybody good? All right, so let's just have some drill. Whoops, that's the end of that book. Let's have some drill with the power rule. Drill using power rule for derivatives. All right, and I'm going to start easy, and we're going to build up, and I'm going to try to make them as ugly as I can eventually. All right, no, challenge you. No, make it more fun. Excuse me, let's back up. We're going to start out easy and get more fun as we go. All right? All right, let's go y equals x to the 10th. Find the derivative and use proper notation. Okay, in unison, what is it? 10x to the 9th. Next example. Y equals 1 over x to the 10th. Okay, what is it?
-10 times x raised to -11.
-10x to 11.
What's 10 to the 9 over x to the 11?
Okay.
What's that 1 over 10x to the 9? 10 over x to the 9.
All right, I'm trying to write down all the things I heard. Did I hear anything else?
I said -10
That's negative.
Negative 10
to the x to 11.
x to the 11th
-11.
minus 10 x
Oh,
to
yeah,
the
yeah,
minus
that
11.
Minus 11, that's what I said.
All right. This may be one that you want the red pen floating around on again, because people miss this. All right, let's go back to the power rule. It's called playing the game. Everything has to match up exactly before you can use the rule. It has to be written as x raised to the r. It can't be any other form but the variable x raised to a r before you can apply the rule, play the game. This is not x raised to the r. This is 1 over x raised to the 10th. So before we can play the game, use the rules, we got to rewrite this as x raised to a power. So that would be written as x to the -10 using our properties of exponents. All right, let's have true confessions. Who missed it? Oh, several of you did. All right, so send that red pen around, because if you miss it now, you want to, when you're studying for your test, doing your homework, that you keep alerting yourself to little places you missed during class to learn from it. All right, so had to fit the rule. Fit, rule, Exactly. All right, so now we're ready to take the derivative. We'll bring the negative 10 down in front, rewrite, and I highly recommend that you make less mistakes if you'll write negative 10 minus 1. Actually put that little step in it. You brought the 10 down, rewrote, and that exponent is going to be decreased by 1. So you get negative 10 x to the negative 11. And we would like to rewrite these without negative exponents. And remember, the exponent only goes with the base that it's next to. So this is the same thing as negative 10. This is a step you probably want to leave out, but I'm just going to do it. 1 over x raised to the 11th. So you get negative 10 over x to the 11th, which is
The middle.
none of those. This one would have been partial credit right there. Okay? All right, everybody good? All right, let's go for another one. Fit the rule exactly. Sample number 3. F of x. Did you use proper notation? Everybody using proper notation? All right, f of x is equal to the square root of x. F of x is equal to the square root of x. Okay, how did you rewrite it so you could apply the rule? X to the 1/2, correct. Now it fits the form x to the r. So we'll bring the 1/2 down, rewrite, and decrease that exponent by 1. 1/2 minus 1. So we have 1/2 x to the negative 1/2. 1/2 times 1 over x to the 1/2. You could leave it as 1 over 2x to the 1/2 if you want to, but probably you would like to switch it back to a square root. 2 times the square root of x. How many got that right? Raise your hand and be proud. Not every single person. Tell me what you missed. Somebody who missed it.
I didn't simplify it all the way.
Okay. You left the negative exponent? Okay, try to think. Yuck. Negative exponent, got to get rid of it. Okay, what else? What did somebody else miss? Anything? What'd you miss?
I had 1/2 over x to the 1/2. Is that the same?
1/2. Oh, like this? 1/2 over
Yeah, x to the 1/2.
x to the 1/2. Okay, so this is really a compound fraction because you have a fraction over a number. Let's see here.
Multiply by 2 over 5.
And so when you have a half divided by, you invert and multiply. So you didn't simplify your compound fraction, and then you would have gotten right there. Okay, that's called a compound fraction when you have a fraction over a fraction, and that's not normally considered simplified. Okay, thanks for sharing that. Yes?
On a test, would you accept 1/2 times 1 over x to the 1/2?
Well, let's say that's perfectly correct, but this is better.
Yeah, but would you accept the other one without taking points off on a test? Since it's correct and not better.
Well, if the instructions say simplify, then that is because you're still showing the multiplication there. So I usually put simplify. So this is what I would expect. How many points I would take off, I don't know how much the problem's worth. You know, if it's worth 5 or 6 points, I'd probably take off a point for not cleaning up when it said simplify. This is really not simplified. You still have a multiplication expression. Simplified means get it down to a single expression. Okay, let's try another one. f of x, this is example 4, right? F of x is equal to 3 raised to the 5th.
Y equals. Y equals. But there is no line.
It's
just y
it's
equals
horizontal line,
line.
so its slope is 0.
Perfect.
Yeah, so then we-
Perfect. F of x equals 3 to the 5th. That's just a horizontal line, just like you said. This is the line y equals 3 to the 5th, whatever that happens to be,
243.
which is exactly 243. Thank you very much. This is the x, and this is the y-axis. So it's the line y equals. It's a horizontal line. And when you're asked to find the derivative, what is the slope of this curve at any point, and you tell me 0. Slope is 0. Now, why did I not just go 5, 3 to the 4th?
Because it'd be wrong.
Why else would it be wrong? There's no x there. Absolutely. The rule is,
You're good, you. You're good.
you are good. The rule is, it is the variable x raised to the r, not some little number like a raised to the r. It is the number x. It is the variable x raised to the r. Very good, very good. Must follow the rules. All right, next example. F of x is equal to 12x minus 3. And I want you to find the derivative. F of x is equal to 12x minus 3. Find the derivative. What is it?
12 over
12. Excellent, excellent. Somebody tell me why the derivative is 12.
Because A equals 12.
That's a straight line. That particular straight line has y-intercept -3, has slope 12. The derivative is the slope of the curve at any point. And if this is a straight line, no matter where you are on that line, that slope is 12. So therefore, the derivative is 12. Okay? Now, let's stretch our brains, even though it's not in this particular section. Exactly. Somewhat it is. Let's stretch our brains a little bit. Up here in problem number 4, you told me that 3 to the 5th, the derivative is 0. If you'll remember back when you did pre-calculus, you created new functions from old functions by adding, subtracting, multiplying, dividing, composition. So this is really a combination of two functions, one that's called 12x and another function that's called -3, and they're added together. So when you had a constant up here, the derivative was 0. So when you look right here, this is part of some functions added together. The derivative of a constant is going to be 0. This part right here is just the graph of the line y equals 12x, which has the slope 12. And so we can see the slope here is 12. But if I wanted to try to apply the rule to 12x to the first, 12x to the first, let's just try applying that rule to that little part. There's a 12 there. That's just a constant times it. All right. What would be the derivative of x to the first? Bring the 1 down, rewrite x to the 0. And x to the 0, a number other than 0 to the 0. X to the 0 is 1. So we get 12 times 1, or 12. All right? Everybody hanging here with me? I'm going to give you a hard one that's not in this section, but we're going to see if we feel good about ourselves. All right, I'll go ahead and label hard. It's hard at this point. All right. Think about what I just did. I want you to take the derivative for me. F of x equals x cubed plus x plus 7. And tell me what you think the derivative is. Okay. Somebody impress me. What is it?
3x squared plus 1.
How many got 3x squared plus 1? Very good. You just take the derivative term by term. These are added together, so it's like adding 3 different functions. The derivative of x cubed is 3x squared. The derivative of x to the first, 1. You can think of that as a straight line, or you could bring the 1 down, rewrite, decrease it by 1. So it's 1 times x to the 0. X to the 0 is 1, so that slope there is 1. And then the derivative of a constant, you're thinking of a horizontal line, is 0. All right, let's try another hard one. Can I increase it a little bit and make it a little harder?
Shoot for it.
All right, not too much then. F of x is equal to, all right, 5x cubed. What do you think that might be?
15x squared.
Right, it's going to be 5 times, because you have a constant, 3 times x squared, or 15x squared. All right, let's try another one. 4 over x cubed. 4 over x cubed. I want to know what the derivative is. 4 over x cubed. How did you rewrite it before you took the derivative? Yes, you got to make it fit the rule exactly. So we're going to write that as 4 times x to the negative 3. Did anybody forget to write it like that? Pass that red pen, because you do need to mark that. Pass him the pen. Who else forgot it? Keep sending that red pen around. All right, so it's this x to the negative 3 has got to fit our power rule exactly. All right, so now we have 4 times. I'm going to bring the negative 3 down, rewrite, decrease by 1. So I have negative 12x to the negative 7. Negative 3 minus 4 is negative 7.
Just by 1.
Well, who wonders why that became that? Not me. 4. Negative 4. Negative 3 minus 1. I had my brain on that 4. I'm so sorry. Thank you. Keep me straight. Now I confused everybody, so I'm going to start back here. All right, I needed to rewrite it to fit the rule, 4x to the negative 3. So I wrote 4 times. That's only because this is a constant times it. I brought the negative 3 down, rewrote, and write this as minus 3 minus 1, decrease it by 1, and I get minus 12x to the negative 4. Am I correct now?
Yeah.
And then how do I rewrite that without the negative exponent?
Negative 12 over x raised to 4.
Perfect. Negative 12 times the 1 over x to the 4th. Negative 12 over x to the 4th. Okay, good. All right, let me see if I can find a harder one. And then we're going to go to the textbook exercises. You guys have done about as hard as you can do at this point. I can't think of a hard one. All right, just
Multiply that?
Doing this.
Oh, that's right.
The last.
anybody want to help me make it up? That would help. Oh, I got it.
Thought you wanted our help.
Okay, well, I'll start with whatever you want. All right, so here we go. 3x squared plus 1 over 3x squared. All right. Find the derivative.
X to the -1. What? You can't have the 3 here if you're going to put it in. It has to be,
How am I going to write this last term 1 over 3x squared so it fits the rules exactly?
1 over 3 times x raised to minus.
Yes. 1/3 x to the -2. Remember, it's only this x that the 2 goes with. So this is like 1/3 times 1 over x squared. So you have 1/3 x to the -2. Do I need to pass some more colored pens around? This gets missed on tests. There's always a problem on a test like this. All right. Chapter 0, practicing with your exponents. All right, so now we're ready to take the derivative. Derivative of 3x squared is 6x. That was too easy, right? Okay, plus. Now what do we do?
-2 times
Okay,
Well, that
1/3
one's
times -2x to the -2 minus 1, putting in all the steps. So we have 6x plus 1/3 times -2 is what, a -2/3, x to the -3, and let's clean that up. 6x, how would you rewrite this? Minus 2 over 3x cubed. Okay? Questions? All right, this was very hard. Very hard. So watch it. Watch it. It's very hard for this day that we're doing the basic derivatives. After about tomorrow, it's not hard anymore. Okay? All right, we're going to go to some of the exercises in the end of the chapter and make sure we're good at it. All right, I'm on page 75. And I hope you say, oh gosh, these are so easy after all you put me through today, Ms. McCollum. Well, let's start with the practice example right in the middle of the page first. We're supposed to refer, this is page 75 in your book. We're supposed to look at this figure. And it says, what is the slope of the curve at the point 3, 4? What is the slope of the curve? Well, they were nice enough to draw in a tangent line for us. The curve is in blue, and they drew in a tangent line. So if I want to know the slope of the curve, then if I figure out the slope of the tangent line, then I'll know the slope of the curve there. All right, well, if I have the line there, what's an easy way to figure out the slope of the curve? I mean, slope of the tangent line.
Slope.
Yeah, I'm just going to find a couple points that are easy to see. And to me, it looks like that it goes through the point 1, 0, and the point, looks like 2, 2. Would you say that that's the point 1, 0 and the point 2, 2 on the tangent line?
Mm-hmm.
Or I could use the point 1, 0 and 3, 4. That's for sure a given, correct? Yeah, so all we have to do is find the slope with 2 points given on the tangent line. So we have the points on tangent line. We can use the point 1, 0 and the point 3, 4. So the slope of the tangent line, difference in the y coordinates over the difference in the x's, and it looks like we have 4 over 2, or we have slope 2. That is the slope of the tangent line to the curve at the point 3, 4. So now we know the slope of the curve at the point 3, 4 is also 2, correct? What is the equation of the tangent line at the point x equals 3, 4? Tell your neighbor. What is the equation of the tangent line at the point x equals 3?
Oh, here. Equation tangent line where x equals 3.
What is this?
X equals 3 or 4. Isn't that
Okay, what do you need to write the equation of any line?
Isn't that it?
Slope and a point.
Slope and a point.
9 minus 3.
And we are on this curve, we already know the slope is 2, and we know the point is 3, 4, correct? So is everybody going with the efficient point slope form? Y minus what?
4.
4 equals
2.
2 times
X.
x minus 3. That's good enough right there. Everybody got it?
Mm-hmm.
All right, let's look at the next question. What is the equation of the tangent line? This doesn't go to this figure. Okay. What is the equation of the tangent line to the graph of y equals 1/2 x plus 1 at the point 4, 3? So you're going to write the equation of the tangent line at the point 4, 3, and the equation of the line is 1/2 x plus 1. Let's don't do any work here yet. What's this graph y equals 1/2 x plus 1 look like?
A line.
A line?
Straight line.
Straight line. So what is a tangent line to a straight line? The same line, right? So it doesn't matter what point it is on the line. Wouldn't it be the same line? If you've got a straight line, the straight line and the tangent line at any point are the same thing. So do you need to do any work for problem number 2? No. The tangent line and the line itself would be the very same. All right, but let's think about that you didn't use any common sense. So you're going to go in there and work really hard. All right, what would be the slope of this line, which is the derivative? What's the slope? The slope is 1/2. The point is 4, 3. So let's write the equation of the tangent line like we weren't thinking ahead. Y minus 3 equals 1/2 x minus 4. And let's rewrite this in the form y equals, and you'll see you get the very same line back. Y equals 1/2 x, 1/2 of 4 is minus 2. I'm going to add 3 to both sides. Y equals 1/2 x plus 1. That's the same line itself. So this was a question that if you thought about it, if I have a straight line and the tangent line are the very same. So no matter what point you are on the line, the tangent line would be the same as the line itself. Everybody got it? All right. Now let's look at a couple exercises. I think these will look easy to you. I'm on page 76, and we'll look at number 5. Oh, that's a homework question. Number 6. We'll look at number 6. In this problem, you're supposed to estimate the slope of the curve at the given point, and they went in and drew a little tangent line for you. Perfect. That's a horizontal line there. What would you say the slope of this curve is at P? 0. Let's go to number 8. Number 8. Here's the curve. They put a little P right here, and can you see right here is a little tangent line? And the slope of the curve is the same as the slope of the tangent line. What do you estimate that slope to be?
1.
Let's see. Yes. Go up 1 over 1. 2 points on the line. Up 1 over 1. So that has a slope of 1 if you count your grid. Everybody good and happy? All right. Question numbers 9, 10, 11, 12, 13, 14 right here. We're supposed to refer to these points, and we're going to say which one has the biggest slope next to it or whatever. Well, what we're going to do is just say, is it a very positive slope or a very negative slope or whatever. Would you say A has a positive slope or negative slope? Positive, and it's not real positive, is it? What about B? Very positive slope. I'm not going to point out C. What do you think C is? 0 slope. What about D? Very negative. What about E? 0. What about F? Sort of negative. Right. You guys are good. You're experts, experts, experts. All right. I'm just going to flip over to 77. And this is just the curve of y equals x cubed. Y equals x cubed. And they're telling you, because at that point you didn't have the rules, the derivative is 3x squared. Slope of the curve is 3x squared. The question would be find the slope of the curve at the point. So if you had the point 2, 8 on this curve, what would you say the slope is? Yeah, just plug in 2 into the formula. 2 squared is 4. 4 times 3 is 12. The slope of the curve at the point 2, 8 is 12. All right, well, section 1, 2 turns out to be pretty easy after you've done section 1, 3. Let's go to the end of the exercises on 1, 3. I'm on page 89. Page 89. And we're just going to look through some even ones pretty quickly. Even. Number 2, you're supposed to tell me what the derivative is. Number 2 in unison. What is the derivative of number 2? Oh, can you focus in a little further? There you go. Is that good, everybody? All right, what's the derivative in number 2? Negative 3. How about number 4? Everybody say it together. 19x to the 18th. What are you going to do to number 6 before you take the derivative? Write it as x to the negative 1/2. I'm just going to keep going down. I didn't take the derivative of x to the negative 1/2, but you have to write it as x to the negative 1/2. Let's see if we can visualize that. So you bring down the negative 1/2, x to the what power? 1/2 minus 1 is negative 3/2, right? Negative. Maybe we better do that one.
Negative 1/2.
Oh yeah. I keep wanting this hard problem to come up that I always seem to come up with. I'm sorry. I wanted it.
I was like,
I can't tell you that these tests I've made out in the past always end up with an x to the negative 3/2 for an answer, and students don't know what to do. That's where my brain keeps going. I'm sorry. So you wrote this as x to the negative 1/2, right?
3/2.
Yeah, just go ahead and remember, if you don't know something on the test, make it a x to the negative 3/2. All right. So bring the negative 1/2 down, rewrite. Oh, I was right.
You were right.
You guys were making me think I was.
We did one minus.
All right. So that's minus 1/2 x to the. That's right. This problem shows up on tests all the time. Okay. So how are you going to rewrite this? negative 1 over 2x to the 3/2. And that's perfectly fine to leave it right there. It's perfectly fine to leave it to the 3/2 power. Okay, yeah. Students have trouble saying negative 1/2 minus 1 and coming up with a negative 3/2. I knew it was somewhere in here. Okay, let's go back to the book. Number 10. Zoom in a little bit. Okay, there we go. Thank you. Problem number 10. What is that derivative?
0.
You guys are good, good, good. How would you rewrite number 12? That's a 1 over x to the negative 5. How do you rewrite it before you take the derivative? X to the 5th. Correct. All right, let's make sure we understand all the instructions. Exercise 17 to 24. Find the derivative at the value. So let's look at problem number 18. If you're supposed to find the derivative at 2/3, what do you do first?
5x to the 4.
You get the derivative in general first. Right, you get 5x to the 4th, and then put in your 2/3 for x, correct? Yes. You guys are good. Question number 26. Find the slope of the curve at x equals negative 2. What are you going to do?
5x to the 4.
Find the derivative and put in the negative 2. They're giving you a drill on the instructions. First, it just told you to find a derivative at a point. Then it's using other terminology meaning the same thing, slope of the curve at a point. All right, problem number 28. That one's too easy. Let's go to 30. I just want to know how you do it. F of x equals 1 over x squared. When it says compute f of 5, what are you going to do? Just put the 5 in where the x is because it's saying what is y when x is 1 over x to the 5th. Then it says find the derivative at 5. What are you going to do? Find the derivative and then plug in. You are perfect, perfect, perfect. Let's go over to problems 33 to 40. 33 to 40. In these exercises, you're going to write the equation of the tangent lines. So for a problem like number 34, you've got f of x equals x cubed, and you're going to find the equation at x equals negative 2. What are you going to do? Find the y value first by putting the negative 2 into x cubed. And so you got a point, and then how are you going to find the slope? Take the derivative and put the negative 2 in, and then write the equation of the tangent line. Okay, let's move on down the page. Number 45, for example, and then we're going to have to quit. I know you're sad. Find the point on the curve where the tangent line is parallel to y equals x over 8. The tangent line is going to be parallel to this line. What do you know about parallel lines?
Same slope.
Same slope. So you're going to have to find the slope of this line, which you already know what that is. What is it? Yeah, it's a line, 1/8 x. So the slope is 1/8. So now you're going to find the point on this curve where the slope is 1/8. Right? Parallel lines have the same slope. So this slope, that's a straight line. So the slope is 1/8. So now you're going to take the derivative and set it equal to 1/8. Okay, we did an example earlier like that. Okay, you guys have been good, good, good. And I'm sorry we didn't get the limits, but we'll pick up there tomorrow.